This is lesson 4-9. We're going to be using patterns on tables to help us to solve equations. So let's look here at example 1. It says the table shows the cost of weekend tickets to the Slide and Splash water park. Find a pattern that relates the number of tickets and the cost of the tickets. How much would 6 tickets cost? So we see over on the picture the table that shows that when someone buys 3 tickets, it costs $16.50. When someone buys 4 tickets, it costs $22.04. When someone buys 5 tickets, it costs $27.50. And when someone buys 6 tickets, we have to figure out how much money it's going to cost. Well, in order for us to figure out how much money 6 tickets will cost, we have to figure out how much 1 ticket costs. So if we're saying 3 tickets will cost $16.50, we have to figure out what number that 3 is being multiplied times to get the $6.50. So let's write an equation. 3 times some number is going to equal $16.50, 16.5. Let me try that again so that it fits. $3 times some amount is going to equal $16.50, 16.5. We have to figure out what that blank is, so we're going to plug in a variable. Now, I don't want to use n and I don't want to use c since those are already variables in the word problem. So let's choose a different variable. Let's just do x. 3x is equal to 1650. So now if we solve for x, we will figure out how much 1 ticket costs. So we're going to circle the variable. We're going to draw a dotted line down the middle. What operation is this 3x? 3x is multiplication. We have to do the opposite of multiplication, which is dividing. So we're going to divide both sides by 3. 3 divided by 3 is 1x, and x is going to equal, in your calculator, you have to do 16.5 divided by 3, and you get 5.5. So I would just double check that my pattern makes sense. So let's try it. Well, 3 times 5.5. Is it 1650? Yes, it is. 4 times 5.5. Is it $22? Yes, it is. 5 times 5.5. Is it $27.50? Yes, it is. So now we have to write an equation. What are we doing to the n number of tickets to find the cost? We are multiplying that n number of tickets times the 5.5 times the price for 1 ticket. So we are doing 5.5, right, the cost of 1 ticket, times n will equal the cost for all of the tickets. So that's our equation there. So you either say n, the number of tickets, times the price per ticket, which is $5.50, is going to equal C, or we can rewrite that as 5.5n, because that's multiplication, will equal our total cost C. Okay, so now let's look on the table. Do they give us a value for n or a value for C? We have a value for n there. They say that n equals 6. So now we have to evaluate this equation if n equals 6. So what are we going to do with that n equals 6? We're going to take that value for n and plug it in. So let's rewrite this equation. We will have $5.50 times 6 is going to equal C. Remember, there's different ways for us to write multiplication. We can use the multiplication dot. We can use the parentheses. When I plug in, sometimes I like to just use the parentheses. I think it looks nice. 5.5 times 6, put it in your calculator. What do you get? I got $33. So the cost, C, for 6 tickets will be $33. So our pattern here was that we multiplied the number of tickets times 5.5 because that was the cost for one ticket, and we would get the total cost. And if you look at this little hint over here, it says, how does finding the cost of one ticket help you find the pattern that relates to the variables? Well, if we found the price of one ticket, we could then find the price of 3 tickets or 4 tickets or 5 tickets or 6 tickets like we needed, 100 tickets. Once you find the price of one ticket, you just multiply it by however many tickets you're buying. Now let's look at example 2. We're going to be making and analyzing a table to write an equation. So the question says, Ethan owes his mother $75. He repays his mother a set amount each week. That just means he's going to be giving his mom the same amount of money every week. How much will Ethan owe his mother after 12 weeks? So let's figure out what is information that we know for sure. Well, we know that Ethan owes his mom $75. And we know that he's paying his mom $5. So the question is, how much money will Ethan owe his mother after 12 weeks? So the independent amount here is the weeks. Weeks are going to pass. Weeks are going to go on 0, 1, 2, 3, without mattering how much money he's been giving his mom. The dependent variable, the dependent amount is going to be what is changing. The dependent amount, how much he owes his mother, is how much money he owes his mom after 2 weeks, or after 3 weeks, or after 4 weeks. That amount of money is going to be changing. So we have to write a little equation here. And I'm just going to look at the table. So at week 0, at the starting point, they're saying that our pattern is $75, that's our starting amount, minus, he's going to be giving his mom money, $5 each week. So 5 times 0 is how many weeks have passed. So if we have $75 minus 5 times 0, the 0 for how many weeks has passed, he's going to owe his mom $75. Well, now let's see what's going to happen the next week. For week number 1, okay, he's going to have $75 minus $5 the first week. So 5 times 1. Well, what's $75 minus 5? Because 5 times 1 is 5. 75 minus 5 would be 70. So that first week, he'll still owe his mom $70. Okay, now let's go on to the second week. So for week 2, we would have $75 minus 5 times 2 because it's the second week. So now 2 weeks have passed. So we have to do PEMDAS here. 5 times 2 would be 10. 75 minus 10 equals $65. So after the first week, he owed his mom $70. After the second week, he owes his mom $65. After the third week, okay, we're going to plug in the same thing. 75 minus 5 times, well, it's the third week, 5 times 3. So we would have 75 minus 15 is 60. So each week that passes, he owes $5 less. And so now let's try and write an equation for this. We've noticed the pattern. We've noticed that each week that passes, he owes $5 less. So in our equation, we're starting with $75. right? I'm running out of room. I'm going to try and let's see if I could zoom it out and not mess everything up. I also don't want to give you the answer. Okay, we'll try and squeeze it in up top. You should be doing this in your notebook, though, where you should have plenty of room. So we always start with the amount that Ethan owes. He owes his mother $75. 75. Now we're going to be subtracting the amount of money that he's paid his mom. Well, he'll be paying his mom 5 times however many weeks have passed, 5W. So 75 minus 5W is going to equal A. It's going to equal the amount owed. This is a tricky equation to write. I wouldn't expect you to be able to do this by yourself the first time we're seeing a question like this. But we wrote that equation together. We have 75 minus 5W equals A. I'm going to clear my screen. Let's write that equation again. 75 minus 5W equals A, the amount owed. So now the question is asking us, how much will Ethan owe his mother after 12 weeks? So we're saying that W equals 12. Let's plug 12 in for the W. If W equals 12, we're going to plug it in. So rewrite it. 75 minus 5 times 12 is going to equal A. Wow, we actually have like 2 steps to solve here. We have to follow PEMDAS. First step, parentheses. Second step, exponents. Third step, multiplication or division from left to right. I see multiplication here, so I'm going to evaluate that multiplication. 5 times 12, 60. Cross it off. Bring down the rest. 75 minus 60 is going to equal A. So what does A equal? A equals $15. So after 12 weeks, Ethan will still owe his mother 50. Uh-oh, made a mistake. Did you catch my mistake? No, I didn't make a mistake. The chart just doesn't go all the way down to 12 weeks. So if we have week 1, 2, 3, 4, to continue this chart, we would have 12 weeks. So the pattern is 75 minus 5 times 12. And the amount owed was at $15. But you see how I thought I was wrong, but when we double checked it, it does make sense because the table just doesn't fill the, doesn't go all the way to 12 weeks. The table shows Brenda's age B when Talia's age T is 7, 9, and 10. So Talia's age is independent here. We have the 7, 9, 10, 12. Her age is independent there. Brenda's age is changing based on Talia's age. So we have to figure out a pattern. What is the pattern with Talia's age to Brenda's age? Do you notice anything that's happening when you go from 7 to 2? Is the same thing happening when you go from 9 to 4? And so you have to think about the different operations: addition, subtraction, multiplication, division. So we are decreasing from 7 to 2. So from 7 to 2, well, we're not dividing by a even amount, right? 7 divided by nothing will give us 2. What about subtraction? 7 minus what would be 2? Well, 7 minus 5 is 2. Let's see if we're onto something. The next one, 9. What do we do to 9 to get to 4? Can we also subtract 5? Yes, we can. Minus 5. Let's try 10. 10 is 10 minus 5. 5, like the table says? Yes, it is. So it seems like our pattern of subtracting 5 from Talia's age matches the table. So our equation would be T minus 5 equals Brenda's age, B. Okay, so they want to know Brenda's age when T equals 12. So Talia's age is 12. We know that T equals 12. What are we going to do with that T equals 12? We're going to take the T equals 12 and plug it into our equation. So then we will have 12 minus 5 equals Brenda's age, B. And what is Brenda's age? 12 minus 5 is 7. So Brenda will be 7 when Talia is 12.